What's up everyone, welcome to Notezz and welcome to our next video in which we will uncover the mysteries or the shockers which I gave you in the first video of using the mother and father approach to you know feed the bedtime stories to child, right? So yeah, before moving on, I would like to thanks to some of my subscribers who have commented on the first video. I think it's Mohammed Faraz Ali. Thanks, buddy, for supporting me a lot. He was very much impressed with my NestJS series. And I think the best comment was from, I guess, Fakhir Israr, who got an increment, by watching the NestJS series and all that content on my channel. So, buddy, it feels really good when you see that other people's life are improving just because of you. So, yeah, that release of dopamine and all that chemicals in your body, yeah, that feels a lot good, right? And I think the third one was from Ali Hassan. Yeah, I know a lot of people coming to my channel are because of my NestJS series. So buddy, thanks a lot for supporting me. So with that said, let's start with the current video. Okay, so moving on, I guess the last topic we finished was the difference between compiler and interpreters, and I think you guys right now know that how compilers and interpreters are way different from each other. Okay, so today let me just mark the topics down which we will be covering today. So let me just copy this thing and bring it down, and let's say today we will be discussing about JIT, which are just known as just-in-time compilers. Okay, and apart from that, we will be covering one more extra topic today, and that will obviously be the JavaScript engine and its internals. Okay, the internals of JavaScript engine, and that will obviously be the V8 engine. Okay, and again there are a lot of engines, right? But mostly it's V8 which is currently being used by the developer community. So I guess we will hit V8 and we will see the internals of that JavaScript engine, right? So these are the topics. Let me just bring down my fancy arrows right over here so that we can know where we are going. Okay, so yeah, that's the agenda today. So with that said, let's get started. Okay, so right now we can see that we are having our just-in-time compilers approach. So let me bring the previous screen on which we were working, right? So it was our sorry, not this one. Let me go one step back. So this is the right one. Okay, so you guys remember that I gave you a shocker that if there is an approach in which we could field our child with both the approaches by using the mother, which means the compiler, and the interpreter, right? So the reason is, yes, there is an approach. And if you guys come to Google and let's fetch for our JavaScript docs, and these are the official docs for JavaScript. And let me just open this, and here you can see that we are having our just-in-time compiler approach, right? So if you click on this thing, it will take you to Wikipedia, and it will just give you an overview of what a just-in-time compiler is. Okay, so here you can see that it's saying just-in-time compilation is also known as dynamic translation or runtime compilation. So it is, in simple word, it is just a compilation, okay, which is being done on runtime. Okay, so now let's change the story and let's see that how we can bring this JIT thing into the story picture. Okay, so let's bring back to our diagram. So let's say we know that, yeah, somehow we need to use our interpreters, right? So the interpreter is something which will be delivering the story to the child, right? And the mother is right over here. Okay, so now let's just assume that the interpreter or the father is telling the bedtime story to the child, right? And now what if he encounters a difficult vocabulary? Okay, and let's say that vocabulary might be some difficult word, like let's say misogynist or whatever, right? Again, that doesn't matter. So right now, whenever the father encounters that word while delivering the bedtime story from that book, that word is very difficult for him to convey that what misogynist means, right? So maybe he, at that point, he might be just giving an overview of what a misogynist is, maybe getting the context from the story and delivering the meaning. But let's assume that while the father is delivering the story to the child, the mother is also sitting beside him, right? The mother is just beside him and listening to what father is feeding to that child. Okay, so let's say the mother noted that, yeah, the father was not that much of capable to explain this keyword or this vocabulary misogynist to the child, so mother started searching about this keyword misogynist on the runtime, right, while the father is delivering the story to the child, right? And let's say for the next time the father encounters the same word, the mother can interrupt the father and say that, yeah, this is the real meaning, or this is the real uh, concept behind the word of misogynist, so feed this to child, rather feeding the concept which you're giving to the child earlier on. Okay, so what mother is doing here is mother is just helping father around with some optimizations, right? So this is the concept behind just-in-time compiler. Okay, so just-in-time compiler is some word which is available right when you are executing your code or where you are interpreting your code. It will make all the optimization right at the runtime of your code. Okay, so that's the concept of just-in-time compiler. Okay, so it's such a simple story. Okay, just assume that the mother is sitting beside the father and it is optimizing the concepts or the flows of the father. Okay, and that's what just-in-time compilers are. Okay, so right now you have just got a clear picture of what just-in-time compilers are and how they work. Okay, so now let's dig deep down into the JavaScript engine and let's see that how these two approaches are being used over there. Okay, the just-in-time compilers and the interpreters. And if somehow, before going into the JavaScript engine side of things, I want you guys to know that there are a ton of JavaScript engines available in the market, right? So if you just search for JavaScript engines, okay, so there are a ton of them. Okay, on the Wikipedia I guess they have listed a lot of engines. Okay, so it's V8, it's SpiderMonkey, it's JavaScript Core, it's KJS, it's Chakra, I guess. But I think most of the time we are using V8. The reason is because V8 is the engine behind Google Chrome, and I guess V8 was the engine used by Notezz as well. So a lot of time we are spending time on V8 side of things, right? And SpiderMonkey is also, I think, most popular because it is being used by Mozilla and Firefox and all that guys, right? So yeah, there are a ton of engines, but our main primary focus will be on V8 side of things. Again, whether the engine is based on JIT or based on interpretation, it depends on the engine you are talking about, right? So the V8 can have different workings as compared to SpiderMonkey, and SpiderMonkey can have way of different things as compared to JavaScript Core. Okay, but right now we will be focusing on V8 side of things. Okay, so let's come back to our diagram and let's make it something new. Okay, so let's say we are having our JavaScript engine. Okay, so let's say if I'm having any engine side of things or any logo for that. Okay, there is not for now. So let's bring in the rectangle and let's say this is our very beautiful JavaScript engine. Okay, so it's our JavaScript engine. Okay, so this is the main engine which is responsible for running your JavaScript code inside your browser, right? So this will convert your JavaScript code into the machine readable code. Okay, so let's say we are feeding JavaScript into this JavaScript engine. So let me just bring JavaScript side of things. Okay, so this is our JavaScript code, and let's say we are feeding this JavaScript code into our engine, right? So this is something like this, and let me just turn this logo to yellow if I can. Okay, so this is JavaScript which is being fed to this JavaScript engine. The very first step which the engine perform is that the engine will pass this code through a parser, right? So let me just bring in that parser as well. So this is the parser. Okay, and this parser has the responsibility to I would say check the syntactical errors, that if the written code is valid or not. And that's obvious because if the code is not written in a nicer syntax or in a valid syntax, there is no reason to proceed further. Okay, because if the syntax is gone wrong, you can just stop the execution and you can just throw that error back to the user that, yeah, your syntax is not that much of right. Okay, so moving on. So this is our parser, right? So the parser will take our JavaScript code. So let me just bring that arrow into this thing, right? The parser will take the code and it will check for syntax error, and if there is something wrong, it will just throw back the error to the user and it will not proceed further. Okay, let me just give you an example for that. Okay, so let's say inside our VS Code we are having our JavaScript side of things, we are having just a single file, and let's say I'm writing some code over here with a syntax error, right? So let's say it's const I'm having an array, and let's say that array is 1 comma 2 comma 3 comma 4, and this is our main array. And let's say we are looping over that array with the callback function of for each, and this will take a callback. So yeah, this is our callback, and inside this we will write our main logic, right? So this is our for each method, okay? And this for each method, we know that it will provide me that with that item, right? And I'm just console.log that item, okay? I will just log that item. But now for creating a syntax error, let me just create a break statement over here, okay? And for those who don't know that, yeah, you cannot use break statement inside this for each callback, right? Because break statements are meant for loops, and this is not a loop. This is just I would say a callback function, or a function which is assigned to the prototype object of this array, right? So yeah, this is a syntax error, and let's see that whether we get this item or not, okay? So a lot of developers do think that yeah, the code execution will come at this point. It will just print the number 1, and then it will face the syntax error, and then it will just log that syntax error. But that will not be the case, okay? So once you are having any syntactical issues in your JavaScript code, it will not run a single line of your JavaScript code, okay? So if you just save this thing, and let me just open my integrated terminal, and I'm using Node for executing JavaScript. And again, that doesn't matter whether you're using Node or whether you are executing JavaScript on the front end side. Majority of the things will remain same, because under the hood we are using the same JavaScript V8 engine, right? So let me just bring in Node, and let's say main.js, and once you enter this thing, you can see that it has directly pointed me out that yeah, on line number 6 you are having a syntax error, which is saying that you are using illegal break statement, and there is no item being printed over here, okay? We are not getting that one, okay? So make sure that once you're having a syntactical issue in your JavaScript code, it will not run a single line of JavaScript code, okay? So that is the concept of parser, okay? So the parser is something which will point out the syntactical issues in your code, and once the parser is satisfied that yeah, there are no syntactical issues, the code looks fine, it will pass the code to another block which is known as AST, which will generate the abstract syntax tree, okay? So this is something like this. Let me just make it as AST. AST is known for as abstract syntax tree. And for knowing that how a abstract syntax tree can look like, you can just Google it around, okay? So let's go with Google, and let's search for JavaScript abstract. I would say let's write AST for short form, abstract syntax tree. And this is the site right over here which is saying AST Explorer. When you click on this thing, it will just give you an overview of what the code looks like. So I was just tinkering with this thing, and here you can see that I have pasted the same code which I have used on my VS Code side of things. So you can see that how this will look. So let me just if you write any JavaScript code, on the right side it will show the complete syntax tree, how it will look like when it will convert this code to AST, okay, which is known as abstract syntax tree, right? So here we are having inside body, you can see that we are having a variable declaration, which is this part, and you can see that as you hover the mouse over this variable declaration, it is also changing the color right over here, okay? So this is the variable declaration, and this is the expression statement which is just looping over that, okay? So if you open this variable declaration, you can further read it down, okay? So it's just a binary tree, it's not a binary tree, but it's just a tree like data structure, right? So it's a tree like data structure, and if you just go inside the declarations, you can see that you are having another node with a variable declarator. You can just scroll it down, and you can see the ID, and inside ID we are having our name of array, and that's the name we have given right over here. And inside this you can see array expression, we will be having our data. So there is 1, 2, 3, 4 and 5 different elements, and each element will be having a different value. So it's 1 for the first one, and the second one will be obviously 2, and all that, okay? So this is just converting your JavaScript code into a tree like data structure for interpreter, right? So we do this for interpreter because the interpreter can easily traverse the whole tree and then convert that code into the byte code, and then byte code will be converted into the machine code, okay? So that's the further step which are performed by JavaScript engine, right? So if you come over here, so this abstract tree will further provide the tree to another concept, which is the interpreters, right? So interpreters, interpreter, and this interpreter will take your this abstract syntax tree, and this will convert this code into the byte code, right? Byte code, okay. And just make sure that byte code is not something which you can directly run inside your computer. You must need a virtual machine or something which can convert your byte code back to the machine code, and that machine code can be understandable by all the machines, right? So this interpreter will take the abstract syntax tree, it will give you the byte code. Okay, sorry for that. Let me just bring that arrow down to the byte code side of things. So once you get the byte code is converted by this JavaScript engine back to machine code, right? So this is what you will get back from the JavaScript engine, which will just be the ones and zeros, right? So this is the binary code which will be then fed to machines, and the machines can understand that what you are talking about, right? So that's the whole flow of JavaScript engine right over here, okay. But now the question is that, let's say if this is the flow of the JavaScript engine by using the interpreter, so where does the JIT comes into the picture, okay, the just-in-time compiler. So this is, I would say, this is the father's part, right? This is the way the father is telling the bedtime stories to the child, right? But now let's bring mother into the picture, okay. So mother means JIT, just-in-time compiler, right? So just-in-time compiler is somewhat over here. So the first part of JIT would be the profiler, I would say. So let's bring in the rectangle, and this is the profiler, okay. So this is the profiler, and this profiler is having only one single task, okay, and that task is to look at the interpreter constantly, okay. So it is watching the interpreter constantly, I would say. It is looking at the interpreter. Let me just change this line to dotted line, just give you a difference of what JIT is doing, okay. So this profiler will look at the interpreter, and it is looking constantly, and it will see that, yeah, how can I optimize some of the things which interpreter has not optimized, right? The vocabulary use case, remember? So let's say if the interpreter doesn't know how to provide a better meaning of that word of misogynist to the child, the profiler can take care of that, okay. So the profiler is constantly looking at the interpreter and seeing that how he can optimize that concept of that vocabulary of misogynist, right? So the profiler is constantly looking, and then the profiler is feeding that observation back to a compiler which is known as the just-in-time compiler, okay. So there is one more rectangle involved over here, and this is our JIT, which is known as, again, just-in-time, I would say, compiler, okay. So this is the concept right over here, and then this arrow will move towards this, and let me just change this to dotted arrow. So the profiler will feed that information back to not just, but it's JIT, just-in-time compiler. So this just-in-time compiler will take care of making those optimization, and then what this JIT will do, it will just provide you with the optimized code, and it will provide the optimized code back to the byte code right over here. So this will be just right over here, and I would say this is the optimized code, okay. So again, if you compare it with the bedtime story, okay, so that would just be simple, that the mother is directly telling the child the meaning of that word of misogynist in simplest words, which was not being told by the father side of things, right, the interpreter side of things. So this is what just-in-time compilers do. So while the interpreter is converting all your JavaScript code to byte code, JIT or these compilers just at that time start looking at the code, and they see that where are those points where they can make optimizations in your code, okay. So that's the concept of just-in-time compiler, okay. So right now I think this is the whole flow of JavaScript engine, okay. And the engine we are talking about, right, is the V8 side of things, okay. So it's our V8, and this is how JavaScript engine works under the hood, okay. And here I think you might be confused that what those type of optimizations will be which this JIT is performing, right? So I will just give you some of the examples of how they can optimize the code, okay. So let's move on to our VS Code side of things, and let me just remove everything, and let me just declare a function right over here. So let's say it's a function. I'm naming that function as a test function, and it is taking a number of n. Okay, and right now I'm just creating a for loop, and let's say for let x equals to 0, terminator x is less than equal to n, and I would say x plus plus, and inside this I will just I will declare a variable, maybe let result, and let's say that result is equals to 0. Okay, and then inside this I will say result and plus equals to I would say n. Okay, and that will be not n but I would say x. Okay, and then I will just return the result. Okay, so what this piece of code is doing is that if you provide n equals to 3, so it will just sum the numbers, something like maybe 1. Okay, so it will start from 0, so it will be 0, then plus 1, then plus 2, and then maybe plus up to 3. Okay, so if n is 3, it will just sum up to 3, and if n is any other number, it will sum to that number right over here. Okay, so this is the function which is doing this work. Okay, so let's say inside over here I'm having maybe a code, and let's say for not for, but I am calling this function as test with number maybe like 3. Okay, and this will provide me the result. So let's say const the result, and then we will just log the result over the console. So let's say console.log result. Okay, and if I run this thing, let me just create the statement node main.js. You can see that I'm getting 6. Okay, so it's 3 plus 2 is 5, and plus 1 is 6. 6 plus 0 is obviously 6. Okay, so everything's working fine. Okay, so now this is the code which interpreted has converted into the machine side of things and fed to the machine, right? So interpreter has done this thing. Okay, now let's say this code is being executed for a lot of time, right? So let's say right now if I come and let's wrap this to maybe for let x equal to 0, x is less than 100, and remember x plus plus, and inside this I'm just calling that function maybe 100 times. Okay, so let me just make it something like this. Now what this will do is, so the interpreter knows that whenever I will get this function call, I have to go there and step by step I have to execute all these lines to get the result, right? So this is what the interpreter will do whenever first time he will call that function, right? But we all know that there is just-in-time compiler which is sitting beside the main interpreter, and it will start optimizing it by looking at the function, right? So it will see that this function is having a constant value of 3. Okay, and whenever I pass 3 into this test function, I know that I will get back the result of 6, right? So this I will always get back the result of 6. So this is what I'm getting, right? So what this will do, the JIT will just come into the picture, and it will just replace this function with the number 6 right over here. Okay, and now JIT has already optimized your code. Why I'm saying that is because as an interpreter, I know the interpreter will call the function will be pushed onto the call stack, then it will create all those execution environment. We will come onto that part of things, that how execution context work, what is hosting, and all that concepts. But just telling you that whenever you call a function, there are some extra steps which JavaScript has to perform, right? So for skipping those steps, the JIT is smart enough to know that this will result into 6 every time if I call that function with 3. Okay, so there is no need to call that function, right? Just replace this function call with the number 6. Okay, sorry. So something like this, and it will just result the same. Okay, because I know that whenever I pass 3, I will get the same result. So this is what JIT will do runtime by looking at the code which is being interpreted by the JavaScript engine, right? So just-in-time compiler will come into the picture, will look at the code, and will optimize it like this, right? Now, when the interpreter will come for the second time, he doesn't need to call that function, right? What he will see is just a simple number 6, and it will start executing that code, right? So this is the optimizations which JIT will perform while your code is being interpreted, right? So this is just an overview of how JIT works, right, under the hood, and how it will optimize your code. Again, if there are ways to optimize your code, so there are also ways in which you will confuse JIT, right? and in which you write bad code, and that bad code cannot be optimized by JIT. Okay, and that is what we will discuss in the coming on video. Okay, and how there are some type of code which JIT cannot optimize, right? So this is the difference of understanding the fundamentals of JavaScript, I guess. Okay, so once you know the fundamentals, you can write optimized code because you know that how JIT is looking your code under the hood. So you can write the code which is somehow again in the future will be optimized by JIT, and once it's optimized, you know that your code will run faster, your code will be more optimized, and your code will also be more scalable, right? So that's the concept of learning the fundamentals under the hood of JavaScript, right? So yeah, I would say, yeah, that's it for now. I think we have covered a lot, the JavaScript side of things and all that stuff, how JavaScript engine works and all these things, how JIT comes into the picture and how it can optimize the code. And I think if I come back to my diagram, let's go to our roadmap side of things. And yeah, I think we have discussed the engine, JavaScript engine, the V8 side and the internals, and we have also discussed the just-in-time compilers. Okay, so this is the smart enough idea, I would say, to bring both the approaches of mother and father together. I think I don't know who came with this idea, but yeah, this idea is really good because as time progresses, if you have written good and effective JavaScript code, the JIT will optimize it, and as time passes on, your website will be more faster and faster. Okay, in user experience. Okay, so that's the concept of overall JIT and the JavaScript engine side of things. Okay, so I hope you liked the video, you are getting my content. So we will slowly be moving towards more fundamentals of JavaScript side of things. So I think, yeah, that's it for now. If you're liking my content, so do like and subscribe the channel. See you in the next video. Thanks for watching.